Okay, now we'll figure out these three Laplace transforms. Of course, this will be the easiest one, right? The Laplace transform of t squared. And you know that the n value here is positive 2. So the Laplace transform of this is going to be 2 factorial, which is the same as 2, over s to the 2 plus 1 power, which is 3. And this is it, 2 over s to the third power. And as you can see right here, when you're doing the Laplace transform of t squared, you pretty much just care about this portion of the graph, right? Because the definition says this is equal to the integral from 0 to infinity. So it's just pretty much this part of the graph. And the reason I want to talk about that is because if you look at this, the Laplace transform of t minus 4 and then squared times u of t minus 4, you're talking about this part of the graph. And it's just pretty much you shift this graph to the right 4 times, isn't it? Anyway, let's look at how we can do the Laplace transform right here. Whenever you are multiplying by the unit step function with whatever you have here, you are always going to have e to the negative as. Well, the a in this case is positive 4. So I'll put down the positive 4 right here. But we do have the negative as, right? And we have the s in red, of course, like that. Always do that, okay? Whenever you are multiplying a function by the unit step function, always do this first. And then you do the Laplace transform of whatever you need to have right here. When the inputs match, you can just go ahead and do t, no more plus minus, t and then square, just like that. Let me finish this for you guys first. I will talk more about this later on. Anyway, this is how it works. Whenever you have a unit step function, always do that. And then if they match, just t and then the power. That's pretty much it. No more plus minus. Anyway, this is e to the negative 4s. And then this right here is just that. And you have to multiply 2 over s to the third power. And let me leave it as how it is. Right? That's it. As you can see, these two, they look really similar. And the reason is because, once again, the graph is pretty much similar, right? It's just how to shift it. Okay, let me do this right here for you guys. Because this right here, the graph is totally different now. Because here we do have this jump. This and that, they don't. And even though, yes, right here, it was an open circle, but once again, for Laplace, Laplace is good. You don't have to worry about any finite discontinuity. Anyway, I see that I have a unit step function that's multiplying with t squared, right? So I will go ahead and do this right away. E to the negative 4s, right? And this time, I will multiply by the Laplace transform. Here and here, as you can see, the input don't match. Right here, I have t minus 4, and this is what I have to fix now. Inside here, I will have to put down, instead of t, I will have to put down t plus 4 and then square. And this is how we are going to compromise. If you have the t minus 4, I will look at this and then plug in t plus 4. Same thing could happen right here earlier. If you look at this is t minus 4. Yes. Well, I can plug in t plus 4 into this t. However, t plus 4 and then minus 4 will give you just t, right? So the same idea works. Anyway, this is slightly harder because to figure this out, t plus 4 and then square, we have to square this first. And let me write this down first. E to the negative 4s times the Laplace transform. T plus 4 square is going to be t squared plus 8t plus 16, right? And now we'll figure this out individually. We still have that e to the negative 4s in the front, all right? This is my e. It looks like a 4, I know. I almost wanted to write a 4. Let me put this down again. E to the negative 4s. And now, I'll open the parentheses. Laplace transform of t squared is just that. So 2 over s to the third power. And then plus. The Laplace transform of t is 1 over s squared. And then we have the 8. So altogether will be 8 on the top over s squared. And the Laplace transform of a constant, a 1 or something, is 1 of s. But we have the 16. So plus 16 over s. And that's it. Of course, you don't have to distribute if you don't want to. It's preferred if you leave it this way. Anyway, this is how you take care of the original, and then when the inputs match with the unit step function, and what if the input they don't match, right? So pay attention to these 3 examples, and that's it.